Hey guys, in this video we'll go over some pretty cool tips and tricks that will help you to speed up and improve your workflow using Phoenix FD for Maya. In our first scene, we're going to take a look how to create car trails. In the scene, I have a pretty basic animation of a car, and I have created a Phoenix FD simulator with its default settings around the car. And if we go under the grid rollout, notice that the dimensions of the grid are roughly matching the real-world scale of a car. And scene scale is really important while doing simulations, because large-scale simulations appear to move more slowly, while mid to small-scale simulations have lots of vigorous movement. And in order to get predictable results, make sure you have your scene scale in check. Let's see how we can create the car trails. I'm going to create a fire source, and I'm going to shift select my tires. Then shift select my fire source and add the selected objects to the source. Then I'm going to turn off the temperature because we don't need it for this simulation, and we would like our smoke to stay neutral so it won't rise and it won't fall down. And the next thing that I'm going to do is I'm going to set my discharge to 1. Then let's run our simulation and see how it looks. Okay, we have our smoke from the tires, but the simulator is not following along the animation of the car. So what we can do is we can turn on the adaptive grid and use the smoke in order to expand the dimensions of our grid. I'm going to set my threshold to 0.02, and I'm gonna give it an extra margin of 10, so this will compensate the fast moving car. While we are here, I'm going to set the container walls on the y-axis to jump minus. This way, the bottom of the simulator will act as a ground and it will interact with our smoke. And now, if we start our simulation, we should get a lot better results, and our simulator will expand together with the animation of the car. Okay, looking much better now. Though we need to set our smoke to dissipate a bit, because as is right now, it will stay forever, and the dust in real life settles a bit after time. So I'm going to stop the simulation and let's go into the dynamics rollout, set the smoke dissipation to 0.8. Another really important thing that you should know about is the steps per frame. This is currently set to 2, and this means that Phoenix will do 2 iterations each frame, and it will be able to account for fast-moving objects. The faster the objects move, the more steps you will need, though you should be careful when adding more steps, as they will add simulation time as well. Let's start the simulation again and see how this looks. Okay, now simulation looks a lot better, but you'll notice that once the car stops, our tires keep emitting smoke. One way to handle this is to go over to our source in here and animate the discharge value to 0. But if later the car animation changes, we would have to update the source keyframes as well. And if there are a lot of keyframes, it would be quite tedious and slow. So what we could do is to approach this procedurally and adjust the discharge value based on the speed of the emitter. So we want to emit while the car is moving and not to emit while the car is still. We can do that by using discharge modifiers. So I'm going to select my source. Let's move it a bit to the side so we can see it better. and I'm going to open the discharge modifiers rollout, and from the source, I'm going to pick speed. Now we have this curve that lets us control our discharge. And for each point of the curve, we have two values, position and value. The first one will act as our speed, and the second one will act as the multiplier for our discharge. In this case, let's set the first point to a position of 50. And what this means is that if the speed is 50 or below, it will multiply it by the value of 0. And if I select the second point, if the speed is 100 or more, it will multiply the discharge by a value of 1. And in order to figure out what our speed is, let's go to our simulation route, and we can see that in here our range for the velocity is 1400. So let's run the simulation again and see how it goes. Now you can see that while the car is moving, the smoke keeps emitting, and when the car stops, the emission stops as well. So using the discharge modifiers, we can modify the emission based on speed, or we can emit only from the parts that are pointing in a certain direction. They're really nice and powerful way to control your simulations. In the next scene, we'll take a look at how to create a basic wind tunnel effect. Again, we have our car, a fire and smoke simulator around it, and a sphere that will be used as an emitter. I'm going to create a fire source, then select the sphere, shift select the fire source, and add the selected objects. Then I'm going to turn off the temperature because we won't need it for the simulation. And if we start the simulation now, you will see that smoke gets emitted, but it's not moving. So let's stop the simulation, and from the Phoenix FD menu, create a plane force. I'm going to rotate the plane force so it's facing the car. Then set the strength to 1000 and start the simulation again. Okay, now our smoke is emitting, but as you notice, it's not interacting really good with the car. So let's select our simulator, and from the dynamics route, I'm going to set the conservation quality to 30. The conservation gives the fluid its characteristic swirling motion, and increasing the quality helps the smoke to keep its volume. Just be careful when increasing the quality, as the bigger the value, the longer the sim time will be. And if you need a tighter stream, just make the emitter smaller and increase the grid resolution. Right now we have our resolution very low so that our simulation would run fast. Let's run the simulation again so we can see how the conservation quality affects it. Okay, it looks quite a lot better now. Another cool thing that I would like to show you is, let's select the fire source and turn on the particles. This will create drag particles that will move together with our smoke. Let's set this to 1000 and start the simulation again. If I select my simulator, go into the preview settings and disable the GPU preview, you will notice the particles. Okay. In order to render the particles, you'll need a particle shader. So let's create one from the Phoenix toolbar. Then from the Edit Particle Systems, for the particle set, scroll down a bit and select my particles. Now let's select our simulator first. And from the rendering, I'm going to disable the rendering so our smoke won't get in the way. And let's render out one frame. Okay, we have our particles and they look nice, but a bit way too thick. So what we can do is select the particle shader, go into the point settings and set the point alpha to 001. Now let's render out again. This way we get much wispier and detailed result. In the next scene, we're going to see how to create some dust steps. So in the scene, we have this running guy, we have a fire and smoke simulator, a fire source, and a box that's used as an emitter for the source. And if we run the simulation now, you'll notice that the whole box starts emitting smoke. But in this case, we would like the smoke to come out only where the guy steps. And in order to do that, we'll need to modify the emission with a mask. And for the mask, we'll use a V-Ray distance texture. What it does is to create a black and white map based on the distance between any point in space and an object. Sounds a bit complicated, but in fact, it's really simple. So let's delete the caches so they won't get in the way and open the material editor. So I'm going to type distance in the search bar and create a V-Ray distance texture. For the distance, I'm going to set this to 5. I'm going to set the far color to black and the near color to white. Then from the objects, I'm going to pick our running guy. And in the color balance, I'm going to turn on alpha is luminance. Make sure this is checked for all the textures that you'd like to use in the fire source, so they will be read correctly. I have already assigned a V-Ray material to our ground, so let's just go to the utilities and plug the texture we have created in the diffuse color. And now, if we go to a frame where he's stepping on the ground and render that out, you'll notice that we have white mask around his foot and the rest of the box is black. So this way we can use the distance texture as a mask to modify our emission. And let's do that. I'm going to select the fire source, open the hypershade and plug the distance texture into the discharge map slot. Now let's run the simulation. And now you can see that the smoke is emitted only where the guy steps. And if we turn on the GPU preview, let's disable the reduction. You can see that it's really easy to create some dust steps. In this scene, I have created a sphere and using mParticles, I have created some particles that are emitting from its surface. Let's create a particle shader and from the Edit Particle Systems, select the particle set and pick the Add Particles. Then I'm going to switch to bubbles and render the result. And you can see that this way we get those really nice looking foamy bubbles and we did no simulation at all. What we can do is let's change the color to something bluish, for example, and we can get this really nice scattering. Using the particle shader with native Maya particles is really fast and easy way to get some nice bubbly objects with no simulation at all. In this scene, we have this really cool looking animated particle ring. And the way I created it is by adding an animated torus with some noise and use that as an emitter. Then I created a body force and used the torus to attract the liquid particles. For the liquid source, I have created a volume noise texture and plugged it in the RGB map slot. And if we go to its settings, I have used a Purlin noise, and in the color balance, I have used some magenta for the color gain and blue for the color offset. Then I created a particle shader and picked the liquid particles as a source. And let's start a render and see how it looks. You'll notice that the particles are all light and a bit flat. As we have already simulated our RGB channels, if I select my simulator, go into the output, I have enabled the RGB for the grid and for our liquid particles as well. And as we want to use the RGB channel that we have already simulated to shade our particles, we'll need a way to read this channel and tell the particle shader to use it. So what we can do is select the particle shader and turn on the color map, press the checkerboard, then create a Phoenix FD particle texture. Then from the edit particle systems, I'm going to select the particle text and pick our liquid particles. Then turn on the use color from particle channel and choose our RGB channel. And if we render now, particles are shaded by our RGB channel, though they still look a bit pale. So what we can do is turn up the color intensity. So let's set this to 5 and render again. Okay, much better, but still a bit boring. What we can do to spice up our renders is use bloom and glare effects. So I'm going to turn on my lens effects and turn on the bloom and glare. By tweaking the intensity, threshold, and size value, you can get really nice and interesting effect. So if I increase my intensity, I'll get a lot hotter effect. And if I reduce it, I'll get really subtle bloom. I think that this way it looks great. So let's say that we want to shade our particles by speed. How do we do that? We have already simulated velocity, so let's use this for our particle channel. I'm gonna disable the bloom and glare effect for now and go into our particle texture and choose the velocity channel. Let's render again and see what we get. This is really not quite what we are after. It currently colors the particles using the velocity, and this is a vector. So what we need to do is turn on the remap color and set this to length. This way, the texture will use the speed of the particles, which is the length of the velocity vector. And using the points in here, we can remap the colors based on the speed. How do we find what our speed is? We can select our simulator and go into the simulation raw. And in here, you can see that for the velocity, we have a range from 0 to 279. So we can use this range in order to remap the color of our particles. So let's go back to our particle texture. I'm going to switch this color to something like that, a bit of orange. And let's zoom out a bit. And set this color like that. Now, if we render, you can see that the fastest moving particles will be orange, while the slower moving ones will be blue. And of course, we can change those particles. If I set this to green, and if I set this to red, for example, we can get really different results by just tweaking the colors and adjusting the position of the points. Another really cool thing that we can do is to combine the both methods that we have shown above. So we can take the particle texture that reads the RGB channel and multiply it by the particle texture that reads the speed of the particles. Let's open the Hypershade editor and go into the texture. I have already created some texture, one for the RGB using the settings from before, and one for the speed where I have set the fastest particles to be a bit gray and the slower to be darker gray, and set the color intensity to 2. Then let's create multiply divide node and drag the RGB and the speed remap, and let's plug those in. Then I'm going to select my particle shader and use the multiply node for our color map. And now if we render the result, we get the RGB color, but our fastest moving particles will be brighter. And if we turn on the bloom and glare, we get really nice results. And as you can see, using the particle texture is a great way to shade your particles using the channels that you have already simulated.